everyone, welcome to new session on machine learning. Today we are going to see about unsupervised learning. So unsupervised learning is where you only have input data X and no corresponding output variables. So can you see here in the before supervised learning in before video we have a label here, but here the label is absent. So which means unlike supervised learning there is no correct answers and there is no teacher. So here there is no label, okay? So, no teacher. Algorithms are left to their own devices to discover and present the interesting structure in the data. So, this is unsupervised learning. So, let us learn more about unsupervised learning. So, unsupervised learning purports to uncover previously unknown patterns in data, but most of the time these patterns are poor approximation, as I said here, poor approximation, because in supervised learning we have labels, accurate approximation can be done, but here poor approximation of what supervised machine learning can achieve. Additionally, since we don't know what the outcome should be, there is no way to determine how accurate they are, making supervised learning more applicable to the real world problems. But still, we cannot depend largely on supervised learning. Some of the data are unlabeled. So we have to use unsupervised learning. So how we can use, so come let us learn that. So let us see how unsupervised learning works. Suppose you have a basket and it is filled with some fruits, some types of fruits. So here let us say banana, orange, apple and grapes. So you know this before. Suppose if you don't know anything about this fruit and you have seen the fruit for the first time, what you will do? And if you have to segregate them, you will take a fruit and you will arrange them by considering the physical character, right? So okay, first physical character what we are considering here is color. I'm sorry, here it should be in the green instead of grapes, okay? So by considering color in the fruit basket, I'm taking apple and the red section, and yellow as in yellow lemon and banana, and in green grapes, okay? Here the fruits are segregated according to the colors. Again here there is an group here in yellow. So we have to consider another physical characters like shape. So here, if it is round, then you make it as a make it in the another group, and if it is banana, make it in the another group. So here the segregation is done very perfectly. Okay. Here we did not learn anything before. That is, we don't have any label data, but we have segregated with respect to physical characteristics. So this is unsupervised learning. Without any prior knowledge, we are segregating or we are doing whatever the things we want to achieve with the data, or we are trying to understand the things. So how you will, where are the places where unsupervised algorithms are used? Mainly for determining target market for an entirely new product that our business has never sold before. For example, Mothercare. Mothercare is a company which sells products only for kids. Okay, if it is launching some products for teens, then we can use unsupervised algorithm here. So unsupervised learning can be further classified as clustering, anomaly detection, association, latent variable models. Okay. So clustering. What is meant by clustering? As the name determines, clustering is grouping of things. Clustering allows you to automatically split the data set into groups according to the similarity. Often, however, cluster analysis overestimates the similarity between the groups and does not treat data points as individual. See here, I have marked intensity of emotion versus human emotions. So sometimes the clusters, like see here, it is very high, very angry one, medium one, and here the normal emotions are here. Sometimes these normal, medium one may merge with no, angry one or with the normal one. So in clustering, there are few problems. For this reason, cluster analysis is a poor choice for application like customer segmentation and for targeting. So this is a clustering. And what is and next, anomaly detection. So anomaly detection can automatically discover unusual data points in your data set. So if a data points are very regular and if it follows a pattern, and at some places you will find some abnormality. To detect those abnormality, anomaly detections are used. This is very useful in pinpointing fraudulent transaction, discovering faulty pieces of product. Okay, so I'll tell you where the anomaly detection is used at the end of the slide. And the second one is association. So this association you will find mostly in supermarkets. Okay, association identifies sets of items that frequently occur together in our data set. So retailers often use it in the basket analysis because it allows analysis to discover goods often purchased at the same time and develop more effective marketing strategy. Suppose if you're buying or if you're buying some junk foods, drinks, and also milk products together, and if more number of people are buying these products together, then supermarket will arrange those things in a single rack. See here the drinks are arranged here and the other junk foods are also arranged here because people buy these products together in their various purchases. So by analyzing those things, they are arranging the products accordingly. So here where association is used. And the latent variable methods. The picture I have taken from is Geeks for Geeks, and I'll explain these kind of algorithms in future sessions. Okay, as of now, let us consider this image alone. This method is generally used for pre-processing techniques like for dimensionality reduction and for decomposing the data. So where come dimensionality reduction? If the data size is so huge, for example, if you're considering a satellite data, those images are very heavy to process. So what we can do is we can reduce the dimensionality. Reducing dimensionality means the repeated pixels can be omitted. That is original, keeping the original Xerox or copy images can copy pixel can be eliminated. So these dimensionality reduction is also an unsupervised algorithm type. Okay, and let us see some algorithms. So clustering. K-means clustering is often we used in clustering problems. Principal component analysis, that is PCA, is the dimensionality reduction technique. So this is latent variable models, right? This is the algorithm used here is PCA. And for association in supermarket arranging the things, a priori algorithm can be used. And Rose's algorithm for anomaly detection. This is mainly used in Twitter's anomaly detection. They detect anomalies in the time series. Okay, so these can be looked further in detail in the forthcoming session. Till then, take care. Bye bye.